Hi everyone, I am Pravalika. My new ID is TN567. In this video, I'm going to explain my large scale data structures homework file. This is the command which I have used to run the part A of my code. These are the results which I have obtained for the part A of my code. Here they have asked for the size of the tray for each of that 6 month data sets. Size of the tray for 5000 sequences is 144524. Size of the tray for 50K is 899. 347. Size of the tray for 100K sequences is 1249779. Size of the tray for 1 million sequences is 1411674. From the above size of the trays, we can also say as the number of sequences increased, the size of the tray also increased. They have also asked for a prefix tray with up to one mismatch for all possible 36 more in the segments. Number of matches for 5000 sequences is 4798. Number of matches for 50K is 32906. Number of matches for 100K is 44628. Number of matches for 1 million is 49989. As the number of sequences grows, we can also say that the number of matches also increased, which also means that the larger set of 36 maps has a greater possibility of finding a match, even when allowing for only one mismatch. This is the command which I have used to run the part B of my code. These are the results which I have obtained after running the part B. Here in part B, we have introduced 5% per base error rate. So size of the try for 5000 sequences is 154424. Size of the try for 50K is 1298497. Size of the try for 100K is 2399158. Size of the try for 1 million is 16276532. So by comparing the sizes of part A and size of the try for part A and part B, we can say that the try size in part B is significantly large when compared to part A. Since we have introduced 5% per base error rate, which also increases the number of unique sequences and the introduced mutations, which also resulted in more branches and nodes, which leads to a larger try size in part B. While coming to the number of matches, for 5000 sequences is 2280, for 50K is 14589. Likely these are the number of matches for 100K and 1 million. We can also say that number of matches in part A is higher when compared to number of matches in part B for the same data set sizes, which also makes sense because part A contains error-free 36 mer sequences, which also resulted in more exact matches. In part B, we have introduced 5% error rate, which led to fewer matches. Well, coming to my code, this is my code. This is the .h file. These are the libraries which I have used for implementing my code. Here I have get file and get char arrays. These arrays are used to map characters into their respective indices for effective traversal. Here I have also used get random function. Here I have created class name try node, which also has a children pointer initialized to null pointer. I have also created class name prefix try. Here it has a print fragment function which displays the fragment. It also has compare function which compares the two pointer variables. Also, I have created a constructor for prefix try class and also created destructor for prefix try class. It also performs a insertion operation. Like by using insert function, it also performs insert with error rate. By using this insert with error rate function, it also performs search operations. Also uses print fragment function to display the fragments. So this is all about my header file. While coming to the main code, here I have used read subject data function. Here this read subject data function reads the subject data file into our memory. Here I have used separate functions for question and question P for performing and calculating the try size as well as total number of matches up to one mismatch for both of the questions A and B. Also, while coming to the differences between part A and part B. In part A, the try growth is solely based on the number of error-free sequences, which resulted in relatively compact try size. In contrast, part B introduces 5% error rate per base error rate, which also significantly increased the try size due to more unique sequences. The above differences also make sense. Since error rate introduces more redundancy and diversity, leading to larger try size. While coming to the bugs, I have encountered significant issues with memory allocation and deallocation, particularly when dealing with reading the large data sets, which led to memory leaks. This was also this was resolved by carefully managing the dynamic memory allocations and ensuring proper cleanup, especially in the read subject data function. Additionally, while coming to the optimization, um, one optimization I have used is I have optimized my search function, which was initially too slow for dealing with large data sets. So I optimized it by performing a normal search first, and only falling back to searching with one mismatch if necessary, which also significantly improved my performance by optimizing this search function and allowing it to do normal search first. So by introducing this optimization to perform a normal search first, uh, so if the sequences was found, the search was successful and no further action or searching was needed. So by using this search function, I have effectively performed the searching, which also improved my performance and efficiency of my code. So these are the techniques and optimizations which I have used in my code, um, which led to successful implementation. Thank you for giving me this opportunity.